So I just realised I think the microphone was turned off there. Just saying that the previous two questions, 5 and 6, are not on the current syllabus. You can do them with all the single maths A-level, pure maths to help you, but they're currently on the further maths syllabus. But 7 and 8 are on the syllabus, and we'll look at those too. And we'll go through question 5 at the end for a bit of extension work, which will help you with chain rule and solving differential equations from the pure side. So it wouldn't actually hurt to do those. Anyway, 5 minutes to have a go at this question is enough to get a good idea of how to do it. One minute to go. Okay, so here we go. We've got particle p moves on the x-axis, acceleration p at time t is equal to t minus 4 meters per second. So we're going to do part A. We want to find v. We know that a equals t minus 4. So v will equal the integral of t minus 4 dt. And we integrate that, we get t squared over 2 minus 4t. Now, we've got a plus c as well, remember, because we've got an indefinite integral, and we want to just find out what that plus c is. So when t equals 0, we're told that v is equal to 6 here. So if we put 6 is equal to 0 plus c, we can see our c is equal to 6. So therefore, v will equal t squared over 2 minus 4t plus 6. Now, we want to find the values of t when p is instantaneously at rest. So therefore, that implies that v will equal 0 when it's at rest. So that also implies if we just make this all equal to 0, we get this. Plus 6 equals 0. Times that by 2, we get t squared minus 8t. Let's just rub that out, make that clearer. Minus 8t plus 12 equals 0. So therefore, t minus 6 and t minus 2 will equal 0. So therefore, t equals 2 or 6 seconds. For part C, find the distance between the points when p is instantaneously at rest. So because we know that the velocity, we've got this t squared graph, we're going to have it going like this, and it's going to be between t equals 2 and t equals 6. So the velocity is always down here and is always negative on this side of things. And therefore, we should be able to find the distance between them as being that area there. Okay, so it's not crossing the curve, so there's no cancelling out, so we don't need to worry. So we can just integrate between these two values, between t is 2 and 6. So s will equal that. We get t squared minus, I just realised I made a mistake in my original question, t squared over 2 minus 4t. Plus 6. Good job I spotted when I first did this that I made a mistake. Because what I did, which is easy to do, was I integrated this value here because it was nicer. And that would have given me the wrong answers. So let's just do that integral. Sorry, let's change this symbol here. I was right, do the integral here. So get t cubed over 6 minus 2t squared plus 6t between 6 and 2. And if we put 6 into this and then put 2 into this and we take them away, we get minus 5 and a third, which is this area under here. So the distance is equal to 5 and a third meters. There we go. Right, to see if there's any questions on that one, and then we'll move on to the next question. Okay, question 8. Here we go. Let me just have a look at my answer. I think it's another, it says 8 marks. It's actually roughly the same amount of working as the previous questions. I'll give you another 5 minutes to have a go at this one. 1 minute to go. Right, here we go. So let's have a look at this question. So a particle P moves along the x-axis in a straight line so that at time t equals seconds, the velocity P is equal to v meters per second. Where? Now what you'll see is we've got two functions, one from 0 till 6 and another one when t is greater than 6. So at t equals 0, P is at the origin, find the displacement from P from O when t equals 6. So we can use the first part of the velocity function here, and we're going to integrate this value, or this expression, to find out what the displacement of P will be from O when t equals 6. So integrate this, we get 5t squared minus, what's that going to be, t, sorry, I've written t cubed, that's meant to be t squared there. I was wondering about that because I just couldn't remember doing a quartic when I was warming up on this. So we get 2t cubed over 3 plus c. Now we know that t equals 0 when at t equals 0, we're going to have the velocity equal to 0, and we know that it's going to be the displacement from P from the origin, so that's going to be equal to 0. So this is 0, this is 0, this is 0, so c equals 0. Okay, so we've got the displacement is going to be equal to 5t squared minus 2t cubed over 3. So put t equals 6 into this, so therefore we get x, or s in this case. Sorry, I've changed my variables. I used x when I was doing this before, and I've used s. Put this in, and we'll get 36 out. Okay, when you do 5 times 36, 5 times 6 squared minus 2 times 6 cubed over 3, you'll get 36 meters. Right, part B. Let's move up here. We're going to move into t equals 10, so we're moving into this territory, but we've got to be careful of our plus c. Now the plus c allows us to match up these two functions here, okay, at t equals 6. That's the key thing. So this one, when t equals 6, will have the same position as this one. Otherwise, the object has to jump in space, and it won't. That's not possible, okay, to instantly transport yourself in space and time. So what we're going to do is we're going to look at the s is going to be equal to the integral of minus 432 over t squared dt. Integrate that, and what we get is we get 432 over t plus c. So at t equals 6, we know that s is equal to 36 meters. So we put 36 equals to 432 over 6 plus c. And what that happens is we get c out as minus 36 meters. So at t equals 10, s will equal 432 over 10 minus 36, which gives us 7.2 meters. Right, what we're going to do now, that's the only two questions of that type on this sheet. What we're going to do is we're going to page up now and go and have a look at question 5. And I'm just going to give you a little bit of time just to look at question 5 and go through it all straight away. So you could almost pause at this stage if you want to do the question under time conditions. I will go through this straight away. I'm not going to give you any time because it's actually off the syllabus and this is for extension work. But all the maths we do in this question is actually on the single maths syllabus in terms of the pure maths that we're going to use to help us do this question. Okay, so without further ado, we're going to go straight into this question. So we know that v equals 10 over x plus 6. Now, that's not in terms of time. So that's the thing that's different. That's the thing that's the further maths part of this question, is the fact that v is not given as a function of t, is given as a function of x. Okay, and we want to find a, which is equal to dv by dt. Now, this isn't easy to differentiate, okay, because this is an x and we want the thing to be differentiated in respect to t. But we do know from the chain rule that dv by dt equals dv by dx dot dx by dt. And dx by dt is v. Okay, so therefore we can differentiate this with respect to x and then just times by this to get us our acceleration. So therefore our acceleration will equal v times by dx by dt. So dx by dt, sorry, not dx by dt, by dv by dx. So we differentiate this. We're going to get a minus 1 times the 10 will give me minus 10. And this is x plus 6 to the minus 1. So therefore that'll be x plus 6 to the minus 2. So it'll be all over x plus 6 squared when we've differentiated that. You can do that longhand if you need to check that. Now, acceleration, therefore, will equal v times this. Now, v is just 10. So 10 times minus 10 is minus 100. X plus 6 on the bottom times x plus 6 squared will give us x plus 6 cubed on the bottom. I'm just going to move this little bit over here out of the way so I can carry on. Actually, if I just zoom out quickly, I'll give you a bit more space as well. So I'm going to go through part B. And I've got part B. So, oh no, I found the acceleration of p when x equals 14. So let's put when x equals 14 in. So we're going to get a is equal to minus 10 over 20 cubed, which comes out to be minus 1 over 80 meters per second squared. Part B. Given x equals 2 and t equals 1, find the value of t when x equals 14. So we know that dx by dt is equal to 10 over x plus 6. So whereas before we used the chain rule to help us, this part of the question is a differential equation, which is taught pretty much at the end of the single pure math syllabus. And for my class, it's pretty much the last one of 2 topics got left to do. So what you do here when you want to do this is we get all the x's on the same, all the values on the top of the derivative on this side, and all the values on the bottom of the derivative on the other side. So I'm just going to bring this x plus 6 up to this side. So I get x plus 6 times dx by dt. So all the bits of the x's come over here. And all the bits of the t's, all the 10s or whatever, can go over here. Now, if we integrate both these sides with respect to t, then this just ends up being the integral of x plus 6 with respect to x. And the integral of that with respect to t is just going to be 10t plus c. Integrate x plus 6, I'll get x squared over 2 plus 6x equals 10t plus c. Now we know that x equals 2 when t equals 1. So what we'll get here, let me just do this, 2, that's going to be 4, that's 2, that's 12, that's going to give me 14. Just check, x equals 2, 4, 2, 2 is 14, equals 10t, so that's going to be 10 plus c. So c will equal 4. Now previously I got 16, but I probably made a mistake then when I did that. So anyway, no worries. That looks correct to me. I can't see anything wrong with that. If anybody can spot a mistake there, do let me know in the chat. So we've got c equals 4. So we want to find a value of t when x equals 14. So we now got x squared over 2 plus 6x equals 10t plus 4. And we know that x equals 14, so we get 14 squared over 2 plus 6 times 14 equals 10t plus 4. And when we've put all that through, we get t is equal to 17.6 seconds at the end of all of that. So essentially, all you've got to remember is this. If you wanted to have a go at these types of questions, is when you've got v in terms of x, you're going to need to use the chain rule to help you rewrite what a is. Okay. When you want to find the displacement, okay, when you want to find the distance traveled, then you've got to realize you're solving a differential equation and you need to get all the x's on the left side and all the t's on the right side. It's going to be separating the variables. There are other types of differential equations you can do, but all these questions are going to be of this type, where you can just times by all the x bits to go on this side and divide by the t bits if you're going from this side, or just leave the t's over here. And it's called separating the variables, is the method that this is when you come to do the single maths. Anyway, that will do today. If you're feeling very noble and you want to have a go at question 6, in the notebook, obviously, there's all the mark schemes as well. But I'm not going to spend more video time on a topic which is not on the single maths syllabus for this course. But it is a good extension question for your single maths from a pure maths point of view, because this topic and this topic are both on the pure maths syllabus. So there's no reason why you couldn't do this for a bit of practice to improve your pure maths. Now, the next 2 streams are going to be next week on Monday and Tuesday, and then I'll finish off in the last week of the holidays. So 2 more lessons next week, Monday, Tuesday, roughly the same time. I'll post in the next video, what's it called, when I've set up the stream, you'll find out the exact times and the topics we're going to be covering. But essentially, it's going to be the next 2 topics on the sheets for the pure maths and the mechanics. Thank you.